Okay, guys, welcome. Today we're going to talk about index numbers, and we'll also talk about the CPI, the Consumer Price Index, and a couple other things that are related to that. All right, so first we're going to begin with index numbers. Now, an index number gives you a simple way that you can compare two measurements. Usually when we use index numbers, a lot of times we talk about money, but it can be any measurement, and it's made, we're basically looking to compare measurements that are taken either at different times or in different places, right? A lot of times index numbers are used to talk about comparing prices in the past to prices in the future, prices currently, right? So of course, in order to do this, we pick the value at one of these particular times to be the reference value, and we can find that the index number for, I should say maybe current value, or the value of interest divided by the reference value times 100 would give us the index number. All right, so let's do a quick example of that. So we're going to suppose that the cost of gasoline today is $3.77 per gallon. Now we're going to use the 1980 price as the reference value, and we're going to say that's 122, and we're going to find the price index for gasoline today, right? So our value for today over the value for 1980 times 100 will give us the price index for today, and of course assuming that your reference value is 1980, right? So if we calculate this, the value today is 377. The value in 1980 is $1.22, and then we just need to multiply this by 100, right? So if we multiply here, we're going to get, let's see, so if I take 377 and divide that by 122, and then multiply that by 100, I'm going to get a 309.02. So that would be my price index for today, right? And one way that you can sort of interpret this is that it's essentially a percentage, right? Prices today are 309% of what they were in 1980, at least for gas. Okay, so like I mentioned before, the primary purpose of index numbers is that they're used to make comparisons, right? So if we want to know how much more expensive something was, of course, we take the price index in the time period that we're looking at, and then we multiply it by the price index percentage of the time period that we wish to compare it to, right? So we said that in our last example, we had sort of 309% difference in our prices there. So that's sort of what we would use, right? Now, of course, if you can still do these types of comparisons if neither value is the reference value, but essentially what you're going to do is you're going to divide the index numbers for the 2 years, and then whatever that comes out to be, that will be your index number, right? So you're essentially just sort of doing the calculation first and then reusing that as your index number. Okay, so in this example, we're going to suppose that it costs $15 to fill your tank in 1980, and we want to know how much would it cost to buy the same amount of gas in 2010. All right, so first of all, we have that our price index in 2010 is 232.8, right? So if it costs $15 in 1980, well, then I just simply need to multiply by this index number as a percentage, and then that will give me what the price is currently, right? So if I do that, I need to do 15 times 2.328, right? Because now I'm sort of converting from a percentage. And if I do 15 times 2.328, we'll get that the same tank of gas costs $34.92. All right. So we actually didn't need the price per gallon. Right. In here, we just needed the price index. Right. So just be careful of that. Okay. Now in example 2, suppose that it, well, I guess this is part B. Suppose it costs $21 to fill your gas tank in 2000. Right. So we have the prices $1.56 and the price index is 127.9. Now we want to know how much did it cost to buy the same amount of gas in 1960, all right, where the price index is 25.4. All right, so now we have something that's a little bit different here because in this case, neither value is a reference value. Right? Before we were using 1980 as our reference value for the price index, but now it's different, right? So we have to be a little bit more careful. All right. So we can do two things. I can either take the price index for each time period and divide them, or I could take the prices and divide them. All right. I'm just going to take the price index. So price index. And let's see. And we want to find out what this is for 1960. And I'm going to consider my reference value to be the price index in 2000. And this will give me a new index number. So this will be the new index number. And this will take me from 2000 to 1960, right? So if we do that, we're going to have a 25.4 over a, let's see, 127.9. All right. So if we calculate this, so I need to do 25.4 divided by 127.9, and that will give me a, let's see, and then of course, if I want to multiply it by 100, let's do that. So then we'll get that this is a 19.86 roughly. All right, which essentially says that in 1960, prices are about 19.86% of what they are in 2000. All right, so now we take our $21 and we multiply it by 19.86%, which is equivalent to saying take 21 and multiply it by 0.1986. Okay, so if we do that, times 0.1986, then we'll get that the same amount of gas would cost $4.17 roughly. Right, so much cheaper. But of course that makes sense because if you look at the price for each time period, you're paying much less in 1960 than you are in 2000. All right, so that's sort of the idea there. Okay, and now this is sort of what I was just saying. When we can change the reference value, essentially you're just going to change, by dividing the two numbers that you have, right? And that's what we did in the last example, because we had that our reference value is 1980 for all of our price index, but now we just calculated a new index number by taking those prices and dividing them. Right, so I could have taken the prices and done that as well. Okay, so now we're going to use the 2000 price as the reference value, right, which was 2000 price was 120, or no, sorry, I want the actual price, so 156. All right, we want to find the price index if today's gasoline price is $3.77 per gallon. Okay, so let's first find the new index number. Now, if I'm using the 2000 price as the reference value, that's going to be my denominator. Right, now today's price is $3.77, so that's my numerator. And if I want to find the index value, I'm going to, of course, multiply by 100. So if we find 377 divided by 1.56 and then multiply it by 100, we're going to get 241.67 once we round. Okay, so now we have our new price index, and now we want to figure out, well, how much would a tank of gas in 2000 that costed $20 cost to fill today? Well, now we just take 20 and we multiply by 241.67%, right? So we're really doing 20 times 2.4167. So now if we do that, 20 times 2.4167, and that will give us that this is $48.33. Oops. All right, let's bring it back. Okay, so I gotta scroll back down here. Okay, yep, so then we ended up with $48.33. Okay, so that's a couple examples using the index numbers there. Okay, now we're gonna talk about what's called the CPI, which is the Consumer Price Index. All right, and this will give us a nice sort of application of index numbers. Now, of course, most prices of goods increase as time goes on, and of course, this process is known as inflation, right? So what the Consumer Price Index does is it allows us a way to measure the change of prices versus the rate of inflation, right? So our prices increasing faster or slower than or about the same as the rate of inflation, right? So the Consumer Price Index is based on the average prices for a sample of more than 60,000 goods, services, and housing costs, right? So it gives you a good sort of general description of how prices are being computed, right? So to examine the effect that the CPI has on prices, what we essentially would do is look at the ratios of two different time periods. And of course, here's a table of some of the CPIs for some given years. Okay, so you can see that in general, the numbers are sort of trending upward. And it looks like in here, let's see. Yeah. So and it looks like we cap out at 2012. So we're sort of a little bit behind, but that's okay. So in this example, we're going to suppose that we needed $30,000 to maintain a particular standard of living in 2000, where we had a CPI of 172.2. Now, how much would you need in 2012 with a CPI of 229.6 to maintain the same standard of living? Well, first, we need to find the index number. And we'll find the index numbers by comparing those two CPIs. So again, this is the reference value in the bottom, and then the value of interest up top. Right, so here, our value of interest, we want to find out in 2012. So we're going to put that CPI up here, and then the reference value, we'll put 172.2 down here. All right, so if we find this, 229.6 divided by 172.2, multiply it by 100, we're going to get 133.33. All right, so that's our index number to go from 2000 to 2012. So now if I want to find how much I would need, I'm going to take my 30,000 and multiply it by 133.33%, which of course, again, just means taking 30,000 and multiplying it by 1.33 repeating, which would give you a 40,000. Right? So in order to maintain the same standard of living, you would need $40,000 in 2012 compared to when you would just need 30,000 in 2000. But essentially what this is saying is that those two amounts of money are equal for the respective time periods. Right? So that's sort of the idea. Okay. Now I mentioned a little bit about the rate of inflation, and we can calculate that by using our CPIs, right? So if I want to find the inflation rate from year X to year Y, we're just basically finding a percentage change of the CPIs between the 2 years, right? If you think of your CPI in the new year as your new value, and your CPI in the old year as your old value, then this is new minus old over old, which is just percentage change, right? And to make this into a percentage, you could, of course, multiply by 100%. All right, so let's go ahead and do that. So let's find the inflation rate from 2011 to 2012. Okay, so let's go ahead and let's take a look at that. So here, our CPI in 2011 is like our old, which is 224.9. And our CPI in 2012, which is like our new, is 229.6. So then the inflation rate is 229.6 minus 224.9 over 224.9 times 100. Right, so if we find this, again, we'll let the calculator do the work on this. So I need 229.6 minus 224.9, and then divide that by 224.9. And if I multiply by 100, we're going to get a 2.09%. Right, so the inflation rate for these 2 years is 2.09%. Now, let's go ahead and we'll compare this to the late 1970s, and we'll go back to that table. All right, so we'll pick 2 years that are close together in the late 1970s. So for example, let's just go ahead and let's pick these two. So 60.6 in 77 and 65.2 in 78. In 1978. And in 1977, I think it was 60.6, but let's just double check. Yes, 60.6. Right, so same idea. I want to do 65.2 minus 60.6, divide that by 60.6 and times 100%, and see what we get. Now we see that the numbers are about 4.5 apart here, and they're pretty similar. They're about 4.5, maybe a little bit more in 2011. But what's going to make this much different is that in relative to 60.6, this is going to be a bigger jump. So if I do 65.2 minus 60.6, and then divide that by 60.6, multiply it by 100, we're going to get 7.59%. Right, so a much higher rate of inflation in the late 1970s as opposed to 2011 to 2012. Okay, so one thing that we'll have to take into account here is that when you see prices increase, we also need to take into consideration, we need to take inflation into account. Right, so around the time that I got my license, gas prices were around $3.50 per gallon, right? And the fact that I live in New Jersey means that gas prices are usually cheaper in New Jersey. So $3.50 was on the cheap side, right, for gas prices. So that's, that's one thing to keep in mind. Now, I can remember when I was younger, gas prices were around $1.10, right? So what you might be tempted to say is that gas prices have tripled their value, right? If you multiply 1.10 by 3, you would get 330, and it's even more than that, right? But what we didn't account for was inflation, right? So if you take inflation into account, the price increases are still, they're probably quicker than inflation because the demand for oil has gone up. But if you take inflation into account, the change is not going to be as drastic. All right, so that's one thing to keep in mind. Okay, now to adjust prices for inflation, what we can do is take our two prices, take the price that we want to have, and we find that by taking the price that we know in year X, and then we multiply the ratio of the CPIs in the year we want to know the price in over the year the price CPI that we know the price in. All right. Now, one thing that you can also do that's kind of interesting is that the U.S. Bureau of Labor Statistics provides an inflation calculator on the website, right? So what you can do is you can use this tool to sort of investigate inflation as well. So that's a cool thing to do. All right, but let's look at an example. So in 1987, where the CPI was 113.6, the mean salary for MLB players was $412,000. In 2012, the mean salary was $3,440,000. Now we're going to compare the two salaries in 2012 dollars, and we'll see that how do these prices compare to how they should have risen with inflation, right? So if we base this on inflation, let's do that part first. Right? The way that I could get that is that the salary in 2012 should be the salary in 1987 times the CPI in 2012 over the CPI. I think I have this reversed, actually. I think this should be, oh wait, is that right? No, I think yeah, no, I was right the first time. So CPI in year 2012 over the CPI in 1987. Right? This is how we should be able to find it. And of course, if we did that, we would do 412,000 times the two CPI. So we have 229.6 over 113.6. Right? So if we calculate this, 412,000 times 229.6 divided by 113.6. Right? So prices should have risen to $832,704.23. That was if it was based on inflation alone, right? So you can see that the numbers that we're getting, this 3,440,000 is obviously much bigger than that, right? But now let's compare them both in 2012 dollars. Right? So, and really that's exactly what we just did, right? So, right, in 2012, the salary is 3,440,000. Right? Now in 1987, the salary was 412. Right? But in 2012 dollars, it's this number. It's this 832,704. Right? So you can see that what happened is that the salaries blew up much quicker than the rate of inflation, right? So it made it all the way to 3 million. When if it was just according to inflation, then it would have been 832,704. Okay, one last example for this video. So according to computer performance tests, a Macintosh computer that cost $1,000 in 2012 had computing power greater than that of a supercomputer that sold for $30 million in 1985. Now, if computer prices had risen with inflation, how much would the 1985 supercomputer have cost in 2012, right? And of course, we'll use this to talk about the cost of computers over time. Now, in 1985, let's see, so I'd have to come back and grab this price index in 1985. So in 1985, our price index was 107.6. Let's see, so 107.6, right? And then in 2012, our CPI was 229.6. Right, so then this means that I should have been able to take $30 million and multiply that by 229.6 over 107.6. And that would give me the cost of the computer today, which is obviously going to be much more than 30 million, right? So if I take 30 million and multiply that by 229.6 over 107.6, I'm going to get 64,014,869.89. Right. So it's a good thing that computers haven't risen with the cost of inflation, right? Because if that were true, then this supercomputer in 1985 would be worth $64 million today, right? So this tells you that the cost of computers has decreased in value, right? So it's cheaper for us to make these computers now, which makes sense because our computing power is also increasing as well. Okay, so that concludes this video on index numbers and comparing numbers from different time periods. I hope you enjoyed, and I'll see you next time.